Graphing exponential functions. Like any function, we can graph exponential functions by filling in a table. There are, however, some shortcuts that we can learn as we go along. Exponential functions are functions in which the variable appears in an exponent. Let's start with the simplest case, a number to the power of x. In this case, we have y equals 3 to the power of x. Start with x equals 0. 3 to the power of 0 equals 1, so y equals 1. Graph the point 0, 1, which is also our y-intercept. Now try x equals 1. 3 to the 1 power is 3. Now try graphing 1, 3. Now x equals 2. 3 squared equals 9. Graph 2, 9. Now try 3. 3 to the 3rd power is 27. We cannot graph 3, 27 because it is off the graph. Let's try some negative numbers. 3 to the negative 1 is 1/3. Graph negative 1, 1/3. Try negative 2. 3 to the negative 2 power is 1/9. Graph negative 2, 1/9. The graph gets steeper and steeper as it goes to the right. This is called exponential growth. As the graph goes to the left, it gets closer and closer to the x-axis, but it never crosses the x-axis. This means that the x-axis is what is called the asymptote, a line that the graph never crosses. The asymptote for this graph is y equals 0. In the next case, the only change to the function is that we are multiplying the function by 4. Let's see what happens. Try x equals 0 for 4 times 3 to the 0 power, or 4 times 1, which equals 4. The y-intercept then is 0, 4. Now try x equals 1 for 4 times 3 to the 1 power, which is 4 times 3, or 12. Graph 1, 12. Try x equals 2 for 4 times 3 squared equals 4 times 9, or 36. 2, 36 is off the graph. Let's try negative 1 for 4 times 1/3, or 4/3, which is approximately 1.3. Graph negative 1, 4/3. Try x equals negative 2 for 4 times 3 to the negative 2, or 4 times 1/9, which is 4/9, or approximately 0.4. Graph negative 2, 4/9. Notice that once again we have exponential growth, but every y-coordinate was multiplied by 4, so the growth is much steeper than it was before. The graph still never crosses the x-axis, so the x-axis, y equals 0, is still the asymptote. Now we will learn a system for graphing any exponential function. Notice that in this example a constant, 2, is added to the end of the function. This gives us the asymptote, y equals 2. In the first two examples there was no constant added to the function, so the asymptote was y equals 0. Now look at the number in the exponent, x minus 1. This number is negative 1. Move along the asymptote to the right when the number is negative, and to the left when the number is positive. Move 1 to the right. Now look at the multiplier at the start. This is 4. Count 4 up from the dotted line. The start point is 1, 6. Now find a point to the left and the right of the first point. 2 is 1 more, 0 is 1 less. Let's find 4 times 3 to the 0 minus 1 plus 2. This gives us 4 times 3 to the negative 1 plus 2, which is 4 times 1/3, or 4/3, plus 2. This works out to be 4/3 plus 6/3, or 10/3, which is approximately 3.3. Graph 0, 10/3. Thus we have the y-intercept, which is 0, 10/3. Now calculate 4 times 3 to the 2 minus 1 plus 2. This is 4 times 3 to the 1 power plus 2, which is 12 plus 2, or 14. Now graph 2, 14. This is enough to give us the general shape of the graph. Once again, we have exponential growth. Now let's look at another example. In this example, the only change is that the multiplier at the beginning is negative. The asymptote is still y equals 2. The number next to the x is still negative 1, so we move right 1, but this time the multiplier is negative, so we go down 4. This gives us a start point of 1, negative 2. Now find a point to the left and to the right of the original point. Let's start with 0. Negative 4 times 3 to the 0 minus 1 plus 2. This gives us negative 4 times 3 to the negative 1 plus 2. This is negative 4 times 1/3, or negative 4/3 plus 2, which can be converted to negative 4/3 plus 6/3, which equals 2/3, or approximately 0.67. Graph the point 0, 2/3. Now try the number 2. Negative 4 times 3 to the 2 minus 1 plus 2. This equals negative 4 times 3 to the 1 power plus 2, or negative 12 plus 2, which is negative 10. Graph the point 2, negative 10. These 3 points give us enough information to get the general shape of the graph. Notice that this time the graph is below the dotted line. This is called reflected. Whenever the graph is below the dotted line, it is reflected. This is caused when the multiplier at the beginning is negative. The negative 4 caused the graph to be reflected. In this example, there is only one difference from the original. The ratio is 1/3. The asymptote is still 2. The number in the exponent is still negative 1, so we move to the right 1. And the multiplier is positive 4, so we move up 4 from the dotted line. The start number is 1, 6. Now find a number to the left and right. Let's start with 0. 4 times 1/3 to the 0 minus 1 plus 2. This is 4 times 1/3 to the negative 1 plus 2, which is 4 times 3 plus 2, or 12 plus 2, or 14. Graph the point 0, 14. Now let's try 2. 4 times 1/3 to the 2 minus 1 plus 2. This is 4 times 1/3 plus 2, or 4/3 plus 6/3, which equals 10/3, which is approximately 3.3. Graph the point 2, 10/3. Now we can graph the exponential function. Notice that the shape this time is going down as it goes to the right. This is called exponential decay. This is caused when the ratio is a fraction. When the ratio, the number touching the exponent, is less than 1, you get exponential decay. When the ratio, the number touching the exponent, is bigger than 1, you get exponential growth. In this example, we have a negative multiplier, so the graph will be reflected. It will be a reflection of exponential decay since the ratio is 1/3, which is less than 1. Start with the asymptote, y equals 2. Now, just as before, look at the number in the exponent, negative 1, go right 1, and go down 4 because the multiplier is negative 4. Right 1 and down 4 gives us our start point, 1, negative 2. Now find a point to the left and to the right of the original point. Start with x equals 0. Negative 4 times 1/3 to the 0 minus 1 plus 2. This gives us negative 4 times 1/3 to the negative 1 power plus 2, or negative 4 times 3 plus 2, which is negative 12 plus 2, or negative 10. Graph the point 0, negative 10. Now try x equals 2, which is negative 4 times 1/3 to the 2 minus 1, plus 2. This gives us negative 4 times 1/3 to the first power plus 2, or negative 4/3 plus 2, which can be written as negative 4/3 plus 6/3, which equals 2/3, or approximately 0.67. Graph the point 2, 2/3. These 3 points give us a general idea of the shape of the graph. Notice that the graph is below the dotted line. This is called reflected. It is reflected because the multiplier is negative. Every time the multiplier is negative, the graph will be below the dotted line. Now let's review. Whenever the ratio, the number raised to a power, is greater than 1, the result is exponential growth. This means that the graph rises to the right. Whenever the multiplier at the beginning, in this case 4, is positive, the graph will be above the asymptote, that is, above the dotted line. However, if the multiplier at the beginning is negative, the graph will be below the dotted line. It will be a reflection of what it otherwise would have been. When the number raised to a power is less than 1, the result is exponential decay. This means the graph gets smaller as it goes to the right. The multiplier at the beginning in this case is positive, meaning the graph will be above the dotted line. If that number at the beginning is negative, the graph will be below the dotted line. It will be a reflection of what it otherwise would have been. Please use these notes as you complete your homework. Thank you.